think we did it. Who can say?
Well, the folks out on Slack, hopefully.
Yeah, somebody will tell us, as always. Now
My
I'm a little
headphones.
loud.
My headphones are trying really hard to fail on me today.
Yeah, that's a problem with my headphone output. There's like a little jiggly wire that I need to jiggle, and so sometimes it's really quiet, and then other times it's really loud, and it all just depends on whether it's been jiggled properly.
Yeah, and I think I'm also just like end of lifing so many different pairs of headphones right
Yep.
now.
I buy them in bulk now.
That's what I do
Yeah,
too.
I just like I will go and buy like right now I'm just using the Anchor ones. So I just get
Hmm.
like the little in-ear Anchor headphones. They're like $10-15. All I need really is for sound to come through the sound hole into my sound holes. So it
Yeah.
works. And then if I'm going to do some fancier audio editing, then I've got some Sony.
Oh, for audio editing, you better believe I'm using fancy pants
Yeah, I've got some
headphones.
MDR 7506, and they're wonderful. I really like them. And it's a pretty beefy, pretty tough set of headphones. But yeah, for just like knockabout, like taking on airplanes and if we're gonna listen to a podcast or whatever, or lend to my children and know they're never coming home again, um, then that's what I use. But yeah, so it's it's funny like when you start out in just content creation, you kind of obsess about the tools that you're doing, and you finesse and you think about it really carefully, and you're like, do I like this one, that one, whatever. And then later on, like, here we are. This is episode 544, right? I'm not sure what you're like, but even like when my laptop craps out, like I don't even think about it. I just go dead laptop, whatever will get me back onto the internet. I don't care really how good it is, how bad it is. Like if it has a screen and it will connect me to the internet, that's all I require. And then when that one busts, because it will bust and I will bust it, and same thing. So a lot of that gear, I mean, we hammer on it, and I don't think we even really obsess about what's inside of it anymore.
I do, but I also do programming and graphics. And it's as soon as a computer hits the point where I can contemplate going and making coffee while it's contemplating
Yeah.
processing an image, that's when that bad boy gets replaced.
But don't you remember once having joy from acquiring new gadgets and gear and stuff like
Yes,
that?
now it's like expletive, expletive.
Yeah.
Now I have to go set stuff up
Yeah.
somewhere.
Yeah. If I get a set of headphones or whatever, I know, like if you hook me up to some kind of, I don't know, em- emotion detector, I would just be like, oh, here it is. This makes now I can hear my podcast again. Proceed. So, anyway,
I,
yeah, I just feel like I've completely lost all that just joy for technology. I'm just like, it just make the things go, make it work, stop breaking. That's
I have achieved that special form of lazy where I just kind of leave things scattered about the house.
yeah,
So instead of owning one really nice thing, I'll own like five or six good enough
yep,
things
yeah.
that
Good enough
add
is
up
all
to
you
the
need.
same cost.
Yeah, yeah. Good enough is all you need. Yeah, yeah, absolutely. So anyone looking to make anything, podcast, video, write things, whatever, don't worry too much about your tools. Just good enough.
Yeah.
People saying nice hair, both. Yeah, look at this. I got quite a beard going on, don't I? I'm gonna say hi to some people. Hello to Adam Synergy, Andy Cowley, Beatrix Lidner, Boric Klankar, Chai Latte Nebula, Christian Barrett, Colin Jones, Dan Niles, Dustin King, George Lancaster, Gordon Dewis, Greg Nickel, Guido Bibra, Harry M., John Richards, John Seffield, Kevin Ayers, Linda Sadiq, Michael Baumett, Michael Collins, Rich 901, Paranor, Thomas Sepstrup, and Zapfan. And I apologize if you already said hello to me. We already missed it. Someone in the last video says when the episode starts. So should we cut off the beginning part? It feels like that's wrong. It feels like the episode started the moment we made the camera go, and that's why you're here. And then the actual audio episode, which you can just get as the podcast, that's
Yeah.
available anywhere, and it's
Those are
edited and it's very
edited.
nice. It's very professional. But if you just want the full raw unedited version, that's why you're here. And so it feels weird, but I guess people are just trying to make their lives more efficient. They just want to go straight to the episode, and good on you. If you're wondering what on earth you've stumbled into, we're about to record a live episode of Astronomy Cast, episode 544, the 544th episode of Astronomy Cast, all about how the universe is weirder and more obtuse than we were hoping. Let's tell me when you're ready, ish.
Okay, I'm just getting everyone on Patreon ready to go.
Yeah.
Patreon. I always forget to have that ready, and then there's this moment of blah. And
Yeah, I'm
trying
still
to
waiting
avoid-
for this time when I go, have you got some names for us? And you're like completely unprepared.
Well, today was threatening to be that day.
Right.
Okay, and my headphones. I'm trying to figure out if I need to replace them because they're really, really bad.
Yeah. Just buy them in bulk. Just
No, like
grab another
can I
shovel full
do
of
the
headphones.
episode? They're that bad.
Oh no. Okay.
Yeah, I'm ditching them. I'm sorry.
Okay.
I can't deal
Abandon.
with this.
Whoa. Ground control to Dr. Gay.
Okay, you get to deal with the not in use flag of
Yeah.
the microphone. But oh, you sound so much better now.
All right.
It doesn't hurt anymore.
Right. Now you ready?
Yes.
Okay.
Once I figure out where I put Audacity. I clicked the button and it bounced and it didn't actually open.
Okay.
It did that a second time.
Is it recording a thing that exists?
No, like the app is nowhere. I click it, it says it's opening, and then it does nothing.
Oh, Mac, right, of course. The little bouncy at the bottom of the screen. Isn't that adorable?
Yeah. I know. Wow. It's like, no, I will not open. Okay, that's all right. I can record in Audition. And I will. I'm not going to give it a choice.
Beware, Susie.
I can export to Wave with the best of them. I just need to tell it to do a new audio file. What is this episode number?
544.
I'm having all the tech fail today. All of it.
Yeah, like I said, it's just, it's a miracle every time we are able to make a thing with the garbage technology that we have to deal with.
Okay, I am now ready.
Let me know when you want to press record.
I am recording.
I am also recording. It's happening. Are you ready?
Yes.
Here we go. Astronomy Cast, episode 544, Weird Issues, Biosignatures. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain, publisher of Universe Today. With me, as always, Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
Good. Are there any updates on Bennu mapping?
Well, we're in phase 2 mapping right now, which means that all of the wonderful 6,000 some odd people that have come to our site succeeded in mapping out the majority of the surface of Bennu. And we now have a specially select group of 8 who each marked over 1,000 images during the initial mapping phase. And that group of 8 is doing a detailed measurement of the 4 potential sample sites, and their data is going into the pool to help figure out exactly where Bennu is going to, well, grab some stuff to bring back to Earth.
That's awesome. Please let us know when the final decision has been made.
We will.
Once again, another place where the universe is going to make this difficult for us, proving once and for all that alien life is on another world. It should be straightforward. Look for biosignatures, but it looks like there are natural sources that could explain almost any chemical we could hope to search for. I think I've admitted this in previous episodes, that I have been a victim of the oversimplification of the search for life. And we've even said this in previous episodes, I know, of Astronomy Cast, that all you have to do, it's easy, Fraser. All you've got to do is search for oxygen in the atmosphere of another planet, and boom, there's life there, because how else could you get oxygen? Turns out you could get oxygen all kinds of ways. So let's talk about this hunt for biosignatures and how it's actually been a lot more tricky. And you put in the Viking experiments, which I think is just, there was a great article. I don't know if you saw this one that came out this week on Scientific American.
Yes.
So it's a perfect time to sort of go over this again and just show how sticky this problem is, and how it's not, the universe is going to unveil its secrets to us, unwillingly. So let's talk about the Viking experiments.
So the Viking experiments back in the 1970s sought to find 4 different ways that through 4 different processes would potentially be able to uncover the reality or the lack of reality of life on Mars. Each of the experiments had a control. Each of the experiments was run multiple times. And most interestingly, in some ways, each of the experiments was run by 2 different spacecraft that were separated by a fairly good distance across the surface of Mars.
All right. So can you explain sort of the setup of the experiment, like, and how they worked, and how these individual, how these different variables were tested for? It's actually pretty incredible.
So back in the mid 1970s, we launched Viking 1 and Viking 2. Each of these spacecraft consisted of a orbiter that would relay the signal back to Earth and a lander that would run the experiments, in addition to having a whole variety of cameras that were used to look around their location. Each of them had 4 experiments. The first of these experiments was a combination of gas chromatograph and mass spectrometer. And the goal of this particular experiment was to determine, are there organic materials? And it was this particular experiment that led NASA to say all the other results were probably faulty. Because when they went looking for organics, they didn't find any. Now,
So how did the experiment work?
They literally scooped up a bunch of soil, heated it, and measured what the composition of the soil was.
And I think they fed it some nutrients as well. So they tried to, or they fed it some, like, I think they warmed it up, and I think they fed it some water.
Well, that's a different experiment.
Oh, different experiment. There was like the limited release.
So there was a gas chromatograph mass
Right.
spectrometer. There was a gas exchange experiment. There was a labeled release
Labeled
experiment.
release, yeah, okay.
And there was a pyrolytic release experiment. So there's 4 different experiments. So the first one that should have been the most straightforward, except this is Mars.
Yeah.
The first one, they just scooped up some soil, looked to see what the soil was made of, looked for some organic materials, and found none. And based on this, they were like, can't be life. Now, the thing is, the Phoenix lander, back during the existence of this show, determined that Mars has a chemical called perchlorate on it. And if you take perchlorates and you put them in a soil sample that contains organic molecules, and you heat this up, the perchlorates politely destroy all the organic molecules, leaving you with exactly what the Viking probe saw.
Right. But with one of the experiments, they did detect carbon dioxide released. You're saying that's from the
So,
perchlorates,
so this is
right?
this is
Right.
so from this first experiment, I'm taking these one
Oh,
at a
okay, okay,
time.
okay. Sorry,
So,
I'm
so
running to
from
the end. I'm
yes, you're
spoiler
determined to
alert.
jump
Yeah,
ahead.
no
You're
problem.
determined.
No, please let this story unfold in its natural order of things.
That I will. Thank you. So in the first of the experiments, they looked for life. They did not find any life, and the result of not finding any life was, or not life, not finding any organics was anytime they found anything else that signified, hey, there might be life here, they're like, nope, gonna ignore it. And this is kind of a key because, well, I'm going to now go to the gas exchange experiment. And in this particular exchange, they took a soil sample and they pulled all of the gas out of the sample and replaced it with inert helium that wouldn't have any chemical reactions. And they also added nutrients to the soil. And the thinking was that if there were microbes in the soil, they would metabolize the nutrients and release, well, whatever they released into the atmosphere of this vessel. And that would be measured in excess of the helium. And both Viking 1 and Viking 2 saw the same concentrations of several gases released, including oxygen, carbon dioxide, nitrogen, hydrogen, and methane. And this is what you would expect if there were
Mm-hmm.
microbes. And so here we have two different gas exchange experiments on two different probes, 4,000 miles apart, that had the same result. Now, the thing was, they also baked the bejesus out of that soil, which they theorized would kill any microbes in the soil, and then looked to see, are there any
Yeah, they baked it. They baked them, and then they ran the experiment again, and they didn't get the gases coming out, which is exactly what you would expect from dead microbes.
exactly.
Yeah.
So here we have a situation of this is doing exactly what you would expect. Now, the argument was, again, why didn't they find organics? And so let's not continue looking at this. And then there was also, when they tried redoing the experiment didn't run quite the way it was expected to run. And because it didn't exactly match, so they're like, oh, this must be some sort of strange chemistry. And one of the critiques that has been put forward for this and other experiments they did is, well, maybe they simply over nutriented it, they overwatered it, and they killed off the microbes with too much moisture. So Mars is a completely dry environment. We've all killed plants before. At least if you've never killed a plant, that probably means you've never owned a plant. Um, so maybe the reason it didn't look identical was they just over nutriented it and killed it in the process.
So everybody agreed, uh, came to terms with the fact that there was life on Mars, was not life on Mars. I'm, of course, being
We're still going. There's still
facetious here.
two more
This fight is
experiments.
still happening. We are 40 years
Yes.
later, and the battle continues.
Yeah. So the other experiment that was done was a labeled release where they fed the theoretical microbes that might be there carbon 14, which is a radioisotope, and they looked to see if that radioisotope would be respirated. And lo and behold, the respiration was observed. They baked the nutrients, no respiration was observed. They've done hundreds and hundreds, and some would say thousands of replications of this experiment using sterile soil, using microbe-rich soil. This is an experiment that no one has figured out how to produce false positives on or false negatives on. And yet, even though this particular experiment showed the expected results on both probes, no life on Mars. So this is the one where the scientist who ran that experiment is just like
Come
over
on,
it
people. What's
with
it
all
gonna
of his
take?
yeah, that pretty much. So then we also get to this is the one I can never say correctly, the prolytic release experiment. So in this case, they were looking to see if they could get photosynthesis to take place. So they gave this one they didn't give nutrients. So in this one, they illuminated the soil, and they looked to see if respiration would take place. They looked to see if carbon-14 that they laced the atmosphere of the soil with would be absorbed by the microbes. They let respiration, photosynthesis, all of those things take place. They then baked the sample to see if any absorbed carbon-14 that was turned into the microbes' bodies. This is what all of us do. We breathe things in, we turn them in, we eat things, we turn them into ourselves. So what they looked to do was see if that taking the C14 and turning it into itself thing microbes can do had occurred. And here they had inconclusive, but probably. And yeah. So you have 3 inconclusive experiments, and by inconclusive I mean it looks like life. And the thing with the prolytic one that left them so confused is here they did bake the bejesus out of the sample, replicate the experiment, and still got signs of life, which could mean that simply whatever it was chose to live through the baking stage.
Right. Life finds a way.
Life finds a way. And we know that things like, well, tardigrades, water bears, you bake the bejesus out of them, like put them on a heat shield of a spacecraft and pass them to the atmosphere,
yawn.
and they still live. And so the poor scientist, now retired, who was in charge of the experiment that looked to see if they could get the nutrients to the microbes to absorb nutrients and release them back out. He was certain that they'd found indications of life, and has spent the entire rest of his career furious. There's no other word for
absolutely.
it.
That is the way to describe it. I mean, when you think about the path that NASA took after the Viking experiments, NASA's takeaway was, this is too inconclusive for us to say that we found anything. And so therefore, let's go back to the drawing board. Let's send the Opportunity rovers to find out if there was ever water on Mars. Let's send Curiosity to find out if Mars was there if water was there for a long time. Let's send Mars 2020 to see if there's any evidence of any life activity ever in the history of Mars, past or present. Like, they spent 40 years getting back to the Viking experiments, and they're not even at redoing the Viking experiments. Like, there's not even anything on Mars 2020 that's going to redo the Viking experiments.
And this is where he gets so eloquently annoyed.
Yeah.
Because Mars Curiosity could have replicated his experiment very easily. It has everything on board except for like the space to do that one particular experiment. If you could do it in the 1970s, you can do it today.
And how?
And he's just like, why won't they replicate this?
Right.
And more than that, he also points out that we now have the technology to not only replicate the experiment, but to look and see if when things get metabolized, get respirated, is the chirality, the shape of the molecules, like the shape here on Earth, or is it something different? And he goes through an entire litany in a, we didn't know this was going to come out when we scheduled recording this episode. He goes through a whole litany of critiques that starts with, okay, we now know there's enough water to sustain microorganisms on Mars. Um, we understand ultraviolet activation of the Martian surface and how this could have affected the experiments. We understand now that there are complex organic molecules on Mars. It was the lack of those complex organics that was part of why they said all of these other potential positive results were actually negatives. Um, the Phoenix and Curiosity found evidence of ancient Martian environments that would have been habitable. The excess of carbon 13 over carbon 12 in the Martian atmosphere is indicative of biological activity. The Martian atmosphere is in disequilibrium. CO2 should long ago have converted to CO in ultraviolet light. Um, we now know that terrestrial organisms can survive in Mars-like environments. There's a rapid disappearance of methane from the Mars atmosphere, but we keep finding methane in Mars atmosphere. Formaldehyde and ammonia, each possibly indicative of biology, are claimed to be in the Martian atmosphere. A 6-channel spectral analysis by Viking's imaging system found terrestrial lichen and green patches on Mars rocks to have identical color, saturation, hue, and intensity. Here he is actually arguing, and I found his original research paper.
That's amazing.
That there is lichen on Mars that the Viking probes could see. And there's a paper from the 1970s describing how the patterns on the rocks change over time in a way that is completely consistent with lichen growing on rocks.
And not only that, but there's an experiment on board the International Space Station where they took a whole bunch of Earth-based life forms, opened them up to the harshness of space, and then returned them to either Earth-based environment or Mars-based environment. And all of the life forms were able to recover in the Earth-based environment, and all or almost all of the life forms were able to recover mostly in the Mars-based environment, and the one that did great was cyanobacteria. So we know of life forms that can make the journey through the vacuum of space, land on Mars, and get rolling again.
Yes.
Not land back on Earth, land on Mars. So we already have life forms that can thrive on Mars, and we have life forms that can handle going to space and then land on Mars and thrive on Mars. So it's like we're learning how much tougher and better life is today. But I think the whole point and why this is all just in the weird issues category is it just shows that obviously if you saw a Martian run past the camera, then you would have proof positive that there's life on Mars. But this is tricky. And
yes.
you ran through a bunch of them. You ran through the methane discovery by Curiosity, of the methane in the atmosphere. That could have been conclusive evidence that there's life on Mars. Nope, because volcanoes can also produce those levels or can produce methane. Right?
So the methane in particular is super annoying because we're now finding that the methane has both seasonal variations and diurnal variations, which means it has a day-night cycle and it has a seasonal cycle. And that gets much trickier to explain as not being life. But if it happens to be that there are ices that have methane from an earlier period trapped in the soils, and those ices just happen to be getting melted and releasing the methane, but this is an ongoing process, and so it keeps the requirements necessary to eliminate this as being life are becoming extraordinarily complicated. And one of the arguments that our poor much maligned Gilbert Levin has put forward that NASA would be covering this up, covering up the discovery of life, is if we are bound and determined to put human beings on Mars, we're not going to do it if everyone knows there is life on Mars that is either going to contaminate our life and kill us, or we're going to contaminate it and kill it.
More likely.
And so his argument for why people are refusing to acknowledge this is it would delay timelines. Now, I don't know what to even say to
Yeah.
that, but I think this is going to be one of my favorite conspiracy theories.
Right, because it's like pretty high up in scientifically rigorous when you think about the people
Yeah.
who are making this. So this issue of we thought we had a slam dunk detection of life on another world. Turns out we didn't. And so now, as we are getting far more powerful telescopes, as Cassini is detecting organic molecules and hydrogen gas in the geysers that are pouring out of Enceladus, as we are seeing these geysers on Europa, and as this next generation of telescopes is coming online to observe other worlds and directly observe the atmospheres of other planets, we once thought this would be relatively straightforward. And I am almost, like I said, I
Yeah.
am almost certain you have said the word something to the effect of, if you see oxygen in the atmosphere, you see life. Would you say that today?
I would say you probably see life. And this is where it gets trickstery. Chris McKay, who is someone whose research I really enjoy following, and he's someone who uses chemistry to find situations that shouldn't naturally exist. So he's one of the ones that's out there studying how so many of the elements in the atmosphere of Mars are not in the ratios that you would expect. He's one of the ones who's been out there studying the environment of Titan and noting that the elements are not in the ratios you would expect, and then looking at possible biological and possible geological reasons for this to happen. And his research is some of the research that is working really hard to say, okay, so here are all the complicated hoops that you can jump through to get these results, but also life.
Right. But as long as there are hoops you can jump through, then you can't say life. And when you think about like the capability of these telescopes, if you point one of these telescopes and you determine the presence of, say, methane on a planet, you don't know how much methane. You just
Right.
know methane, check.
Well, with Mars, we know how much. With
Right.
Titan, we know how much.
Sure. But I'm talking about, you know,
Alien worlds.
yeah, right.
Yeah,
Kepler, whatever,
whatever.
629, right? Something you'll point James Webb at and determine the characteristics of its atmosphere. You can't get that. You can get, methane, check. You can get ozone, check. Oxygen, check. But again, there are natural processes that could theoretically create each one of these, and you don't necessarily get the quantity of them in these atmospheres.
And the thing this all reminds me of is back in the early 2000s, if you went to a series of Mars talks at a conference like Lunar and Planetary Sciences Conference, you would hear a mix of people saying, here are all the ways that you describe the geological features on Mars using everything but water to justify their existence. Here is how you get valleys. Here's how you get everything using dust processes. Fluvial and aeolian were the phrases that kept coming up. And it's the fluvial, the ones that require water, that you also had a minority set of voices at that point going, but water, water. And over the past 2 decades, we've seen this literal sea turn of people saying there were once oceans
Yes.
on Mars now. And so the part of me that really wants there to be microbes out there, we're going to end it at microbes. The part of me that really wants there to be microbes out there really hopes that within our lifetime, all of these gymnastics that we're going through right now to justify methane in all of these places becomes, oh, oops, there's methanogens everywhere.
Hmm.
And we don't know. This is why poor beat up Gilbert Levin
Yeah.
desperately wants these experiments repeated.
Right, right. And as we said, Mars 2020 won't be the machine that'll do it.
No.
Humans who go there, filthy humans covered in microbes, covered in cyanobacteria and lichen, will
I
dig
hope they're not covered in
cover
lichen. That's really a
covered
horrifying
covered in
idea.
lichen. They are so
Okay.
gross.
Okay.
They will dig, they will have, in theory, that's the kinds of tools that you really are going to need. A sample return mission will go a long way, bringing some of those samples from Mars back to Earth. But I think it's exactly it. You land a spacecraft and someone looks over off to the horizon and goes, hey, is that lichen on those rocks over there? And they go, well, let's go check and let's find out that
Yeah.
it's really showing us that from the moment we think we've got the capability to detect some kind of life in this other place to the time when we're sure, especially if it's
Yeah.
microscopic, is actually a lot more intensive and a lot more complicated than we ever thought. And that if we ever thought that any of these secrets would be revealed to us quickly, we apparently have another thing coming, that it's going to take us decades. It's going to take us many
It's
decades. We're at 40 years already with Mars. Buckle up, like, unless SpaceX lands and as well people are out there, I don't know, making their lawns for the new Mars colony, they happen to dig up a Martian skeleton. It's going to take us a while to do either the sample return mission or to have the people there with the proper experiments or the right spacecraft. And same problem, right? You send
yeah.
a laboratory to Mars, it performs a bunch of experiments, and people will think that those experiments might be inconclusive. Back to square one, right?
Right. Right. And I just want this to be definitively proven while poor Gilbert is still
Yes, yeah.
alive.
He deserves a win. He
Yes.
really does. Yeah. And then a Nobel Prize.
Yes.
Yeah, I think that'd be right. All right, Pamela. Do you have some names for us this week?
I do. I have a variety of people I would like to thank for supporting us through patreon.com/astronomycast. It is you and all the things you do, all the money that you give that allows us to pay Susie to keep this show going, to keep herding us, the cats that we are, and to do the weekly production of our episodes. This week, I would like to thank Jordan Young, Burry Gowan, Ramji Amanthu, Andro Palestra, David Trogg, Brian Cagle, the giant nothing, Laura Kittleson, Robert Palesma, Corey Doville, Les Howard, Paul Jarman, Joss Cunningham, Emily Patterson, Josh Hoy, Ed, and Kjartan Sphere.
Thank you, everybody. Again, we couldn't do this without you. See you next week, Pamela.
Bye bye.
Okay. We will save.
And now we save.
544. Okay, I'll upload that in a bit. All right, hit us with your questions if you have such things. Dustin King asks, why don't the Mars landers and rovers have microscopes? Seems like the easiest way to see if there are microbes. Actually, Mars 2020 does have a microscope.
And the others have had varying degrees of ability to look at the surface of things in great detail. The key difference between what they've been able to do so far and a microscope is microscopes shine light through something, whereas what they've had so far shines light onto something. And this difference, allows you to better or worse find life.
Astro YYZ says, a Mars analog on Earth, what variables can be duplicated? Temperature, pressure, atmosphere?
We can easily replicate everything except for the radiation, which we can still to a certain degree figure out. And we don't entirely know the chemistry of the soil. We kind of have to guess at the chemistry of the soil. But there have been experiments done to replicate as best they could the environment of Mars and see if lichen would grow. And the answer was yes. Lichen will just barely survive in Mars-like environments, which means that it may be possible for there to be lichen-like life that is adapted to the Mars environment.
Hal McKinney says, is there a spectrometer on Mars that can be pointed at a distant galaxy to see if redshift observed from Mars is same as the redshift observed from Earth of the same galaxy? And if different, is the universe really expanding? Would you
Okay,
get?
so we don't have any spectrograph that high a resolution,
Yeah.
but I there no, we don't need to do that.
No. So why not, right? Is it that it's not far enough away to get any
Well,
better
so
perspective?
here's the thing. The Earth is moving through our solar system, and we see the same results wherever we are in our solar system. So just going to a planet that's traveling through a slightly different part of our solar system isn't going to change the results we get. Um, if we saw something different, if we are on one side of the sun from the other side of the sun, then there'd be reason to be confused.
Right. And in fact, that's the way that astronomers have determined the
Yeah.
distance to all of the stars within astrometric range is you observe the foreground stars, this old thing, right? You observe the foreground.
Parallax.
Yeah, with parallax, you observe the foreground stars from one side of the Earth's orbit, and then you wait 6 months, and then you observe them again from the other side of the orbit, and you watch how far they've shifted back and forth, and that tells you how far away those stars are. And that's been used to get out to the Cepheid variables, and then the Cepheid variables are used to get you out to the distant galaxies, and so on and so forth. So there's not anything that different. Like if you could maybe position a telescope in Andromeda, that might give you a new perspective that would be helpful.
But
But even
but
that,
no, that wouldn't give you something that's helpful. That would just give you a different 0 point because the
yes.
0 point of our galaxy's motion is different than the 0 point of Andromeda's motion.
Yeah.
But as you average across everything visible in the sky, you get to the exact same set of results.
John Richards asks, what kind of precious metals can we expect to find on Mars?
Same as here. Same ratios, probably even.
Yeah, I'm reading a interesting. Oh, I forget the name of the book. Anyway, some of the things like iron deposits and stuff were actually created in tandem with life here on Earth. So a lot of the big bands of iron were a result of iron-rich bacteria washing down during certain events, or some things like mountains getting eroded and concentrating out certain valuable elements. But essentially, Mars is made of the same raw materials as the Earth.
Yeah. So the distribution is going
Yeah,
to be very different. The minerals that the molecules are tied up in and the atoms are tied up in are going to be somewhat different in some cases, but it's the solar system. So,
yeah. And when you think about some of the big places where people get minerals here in the world, like in Sudbury, they get all the nickel. They have this huge nickel mines and other precious elements from there, and that came from an asteroid strike.
yeah.
So in fact, we're mining. We Canadians are mining an asteroid on Earth to get these really rare heavy elements
Because you can.
because it's there on the ground. Yeah,
Yeah.
yeah, which is such a neat idea. John Sifel asks, actually, Andrew Planet asks, if substantial oxygen was created on an exoplanet before life evolved there, would that be positive or negative for any future life evolving?
Okay, say that again.
If substantial oxygen was created on an exoplanet before life evolved, would that be positive or negative for any future life? Like oxygen was
Yeah.
poison when it first arrived here on Earth.
Right. It killed off all the methanogens.
Yeah. Ha! In your
So
face, methanogens.
So the question then becomes, how would you get substantial oxygen, and would it help the oxygen eating microbes evolve into existence? And we don't know what allows life to exist, so we can't tell you. One of the more interesting papers to come out, I think it was just in the last week, looked at a impact site in Sweden and found evidence of ancient microbial life in the impact site, leading them to think that the conditions of an asteroid impact are actually favorable to the formation of life. But we're only starting to figure this stuff out.
Right. Um, and then John Suffield asks, does that mean that oxygen could have been present on Earth before life evolved? So you're saying, no, you need
We
life.
yeah, we started with methane also, and we wouldn't have had methanogens as our first form of life if we had an oxygen rich environment, because that would have killed the things that evolved first, which would have probably precluded them ever evolving.
Yamagashi-san says that no one can convince me that we should let bacteria slog it out on a cold rock until the sun sterilizes it, when we could use it to do all that we could potentially do. So in other words, they're saying, if we don't touch Mars, then all that happens is bacteria just battles for supremacy until the sun expands and wipes out the planet. I don't
I
think anybody really deeply disagrees with that perspective.
But we do want to study it before we
Right.
destroy it.
That's it. And so if we go, like, you've got to agree that if we go to, if you take, I don't know, some, again, filthy astronaut, just covered in fungus and dripping with bacteria and like a really messy eater, and they're just like walking around on the surface of
They
Mars, and
managed to
they're
track dog shit all the
yeah,
way to
exactly. Dog shit. They're
Mars.
dripping goo everywhere, and then other scientists are going over and they're performing experiments to see if there's life, and there's life everywhere, and it's all astronaut goo. What is this, right? That the goal is, and then you want to talk about unconvincing evidence, right? You don't know, is this life that we find on Mars? Did it form on
Yeah.
Mars? Did it form first? Did it form after? Are we related? When are we related? Right?
We
Because
just want to answer those
yeah,
questions and then take over the world.
yeah, and then obviously grind it up and turn it into an amusement park. But it is the most important question that we can possibly ask. So we have to be careful before we ask it. Can you give us that, Yamigashi-san? Can you give us just a second? And then
A hot minute. We'll take a hot
yeah, we'll
minute.
take a minute just to answer that question, and then feel free to pave it. Glitch Walsh says, why not use Phobos as a staging post first? That is a great
That's
point.
the plan.
And well, not right now.
Well, yeah,
But
that's
I
true.
I did an episode all about that. I hope you saw that.
Well,
So
and I think it's the Japanese are planning to do
Japanese are,
a sample return mission.
yeah, they're planning to send a mission. I believe it's a sample return to Phobos, but
Yeah.
Phobos is actually a really great halfway point to get down to the
Hmm.
surface of Mars. And so there's been some
Friendly
really
gravity well.
interesting, yeah, from the gravity well, some interesting ideas that you send a mission to Phobos, land on Phobos, set up a base, and then try to send some spacecraft down to the surface of Mars from there. So it's actually a pretty great idea. Disk of Accretion asks, where are all the intermediate mass black holes hiding?
We don't know.
Do we know that they
There was
exist?
there was one in LIGO data.
Well, they're in I think the most massive ones are still in the dozens of times the mass of a black hole, but we're not seeing the ones in the hundreds or thousands yet.
No, that's true. That's true.
And that's what you would expect to see.
Yeah.
So it's still a bit of
Yeah,
a mystery.
those yeah, and until we can figure out really how supermassive black holes form, eh, it's not the biggest problem I'm worried about.
Yeah. Um, let's see. Andy
I'm
Cowley.
sorry that I keep yawning. I desperately
Oh,
need more coffee.
yeah. I went off. It's funny. I went off coffee for like the last 5 days. Every now and then, I like to just perform these kinds of experiments.
Self-hating
Well, I just
experiments.
want to know, like I feel like if you said, like, are you addicted to coffee? My answer would be no. I'm not addicted. I can quit anytime I want. And so I went off coffee for 5 days, and I got nappy. I got really sleepy. So I was working in the middle of the day, and I'm just like, oh, I'm so tired. And so I went
Yeah.
over, and that's one of the advantages of working from home. And so I went over to the couch that's down here, laid down, and passed out for 10 minutes, and then
Yeah.
came back. So, and then I was feeling better. So, yeah. Yeah. Thanks, Slackbot. So I think I won't. I will continue to drink my coffee.
It's yes.
Andy Kelly asks, do you think we will ever get a telescope on the moon?
Oh yeah, it's just a matter of time, especially on the far side of the moon. We need better communication satellites with the far side. But the far side is an excellent place to put radio telescopes that won't be susceptible to all the noise created by all of the junk on Earth and around Earth.
And of course, I just did an episode about putting the overwhelmingly large telescope on the moon. But the which is a great place to put a 100-meter telescope.
You can
But
only use it every other 2 weeks.
uh, I
Sunlight.
guess. Well, I mean, no, because it's gonna be pointing at the sun for a while. But if you point it away from the sun, it's still gonna work, right? It doesn't just don't have the sun right in your field of view. Won't a telescope on the moon still work even if it's in sunlight?
The thermal conditions. How do you cool it effectively?
Right, right. Well, it's an optical. Yeah, I mean, it goes between plus 200 degrees to minus 200 degrees, right?
Yeah.
John Seffield says, I recently heard that most of the planets in the universe will be rogue planets, shooting between solar systems and even between galaxies. Is this correct?
I don't think we have the ability to say right now. One of
How
one
do
of
you
the
find a
things
thing
that
you
I
can't
feel
see?
deeply is we don't really understand how the average solar system evolves yet. And until we understand the average solar system, we just can't make any declarations about the majority or minority of anything.
Yeah,
Are there rogue planets? Probably.
yeah.
Are they the dominant planet? No idea.
There have been some interesting ideas about, some super advanced telescopes will be able to do things like watch stars and watch as there are microlensing events as rogue
Yes.
planets pass in front of them in between us and them, and then you could use that to
Yeah.
get a sense of how many of them there are out there. So there are some really interesting ideas to search for these kinds of things, and even primordial black holes and other things like that, things that are dark objects, right?
But the fact that we didn't find any in either the macho or the um so there was one project that looked towards the core of the galaxy and there was one that looked towards the LMC to look for microlensing events. And there were planets seen orbiting stars, but there were no rogue planets detected.
Yeah.
And that starts to put a limit on how many are out there.
Yeah. And that's it. And so you can start to get a limit on how many there are, but you like think about how difficult a time we're having finding, say, Planet Nine, and it's in our solar system.
Right.
So
Right.
imagine trying to find it somewhere not in our solar system
Right.
and not even illuminated by a star. It's the
You can pretty much only find them for microlensing.
Yeah, only microlensing. All right, one last question from Hal McKinney. Why are some stars older than the Big Bang?
Because there's problems with our math.
Right.
It's just a we periodically we oscillate between not understanding how old the universe is and not understanding how stars evolve, and someday we will understand both of these things and the numbers will once again make sense.
Yeah. So at some point, but either the math on the measurement technique for determining how old the stars are or the measurement technique to figure out how old the universe is, we know that one of them has to be wrong. And it's
It's true.
probably, well, it doesn't matter, right? But the point is that you generally would expect to see stars, and stars are in the universe, you would expect to have the universe form before the stars. It's just it's a
Yes.
good backup. Yeah. Astro B says, "Thank you for the Universe Today newsletter. No problem. I just sent
It's
out
a
the
good
latest edition."
newsletter. All
Yeah.
of you need to be subscribing to it.
universetoday.com/newsletter. I send it out every Friday, totally free.
And if you want audio updates of the news that you can then go read in detail on Universe Today, check out my podcast that I do with Annie Wilson. And it's also produced like this show by Susie Murph. It's The Daily Space.
There you go. We got a chance to shamelessly self-promote some of our other work as well. Thank you, Astro B, for reminding me. All right, I think we've reached the end-ish of our hour. We went a little longer to make up for some of the beginning, but thank you, everybody. A big thanks to all of the people who watch us live. Thank you to all of the moderators that watch us live. We couldn't do this without you. If you want to be a part of the amazing community, and of course the little conversation that's going on below our faces, that's at the Weekly Space Hangout crew. Go to wshcrew.space and you will be able to join that. You'll become an executive producer of the Weekly Space Hangout and invite cool guests to the show. Thanks, Pamela, for as always to be doing this show for 544 episodes, and a special thanks to Susie Murph for being our producer and editor, as well as Nancy Graziano for helping to organize and herd all the cats. Couldn't do this without you guys. We will see all of you next week.
Bye.
And now for the uncomfortable cut. Right now.